Everyone, December the 6th. Let's do it today. What do we have? Minimum limit of balls in the bag. You're given an integer array nums where the ith bag contains nums I balls. You're also given an integer max operations. You can perform the following operations at most max operation times. Take any bag of balls. Any bag of balls. Ith bag contains, any bag of balls and divide it into two new bags with a positive number of balls. For example, a bag of 5 balls can become two new bags of 1 and 4 balls, or two new bags of 2 and 3 balls. Your penalty is the maximum number of balls in the bag. You want to minimize your penalty after the operations. Return the minimum possible penalty after performing the operations. So, basically you just split, right? You have a list of numbers and each number can be split. And the max number of split is max operations. And after split, you have to split into two numbers, right? Two numbers. Both must be positive. And then after you do that, you want the maximum of all to be minimum. So it's a min-max problem, right? It's a min-max problem. Min-max problem usually, it's like a binary search can do. So, we have 9. We have max operation is 2, right? So we want to return the minimum possible penalty. Now, minimum possible penalty, you start with 1 to the current maximum, right? 1 to current maximum. So, we say 1, 9, right? Is when we start. And then this gives you a mid. So we have a min, we have a max, and you have a mid. So mid is 5. So we say we try to get to 5, right? Which means we go through everything. Everything is bigger than 5, we need to split. And this bigger than 5 was split. And then it works. So max becomes 5. So we got 1, 5. That'll give you 3. Okay? So every of them is 3 in the split. Okay? So you split. You put it at the end. Is that how you were thinking about? All right? You go through this max number of operations, depending on how many numbers are bigger, right? So we can reduce the number if we sort it first and we go right to left. That is a good idea. And actually, no, it's okay. We just go through the whole thing. Go through the whole thing like 9. Now we need to make everybody 3. So 9 divided by 3. Right? 9 divided by 3. And so you divide it by that. So you have a quotient. You have a remainder. Right? So the quotient is so the quotient minus 1 is how many times you can split, right? How many times you split. And actually quotient is the number of times you need to split. But if the remainder is 0, then you minus 1. So this gives you 2. So that's also good, right? So this is also good. So now we go 1 and 3. So we try to 2. But for 2, this one is 4, right? 4 with remainder 1, which means you need 4 divided 4 times, right? So 2 come out, you have 6. You have 7. 2 come out, you have 5. 2 come out, you have 3, and 2 come out 4 times, but it's longer, so it's not possible. So 1 become 2, so it become 2 and 3. Actually, no, 1 can do 2 plus 1, so 3, so come out. 3 is the answer. Yep. All right, I think we can do this binary search method. Let's try this binary search method. Oh, I think it will be the first binary method in C++ in this new round. All right, so binary search method, we need How do you know which one is the smallest, which one's the biggest? You don't. And it's 10 to the 9th. I don't really think. I think we go through the whole thing to find the max and the min as an easier solution, right? So we say int min equal to, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and max is 0 for n. I think I can do this, right? Yeah. So min equal to max. Oh, is that std max? Yep, max. No, it should be min. Max. Okay. And then with this, now we can say low equal to 1. No, low equal to min. High equal to, usually high equal to max plus 1. While low smaller than high. And might mid shall equal to, I think, low plus high minus low divided by 2. What is C++ integer division? I actually don't know. C++ integer. Oh, yeah, right here. When you divide two integers, the result also an integer. So this is an integer. Okay, so I think this is good. And then we just run through this int ops. Okay, for n of nums. Do they have div mod? You probably had to do it twice. I don't know, you have these things. Oh, div.quote, div.rem. Ah. Both the remainder and the quotient can be represented as objects of the corresponding type. Returns both as an object of type std div t. It's a struct. You have two things. Okay. So we can say auto dv std div right, which one? C standard lib, right? C standard lib and C math. I don't see C math. Which one requires C math? Define here. C math probably. I have no idea. All right. Anyway, so we do that and we say n. No, we do. We say who divided by whom. X divided by y. So it should be. If n is larger than mid, right? If it's larger than mid, then we do this. We say n mid. Ooh, what happened? I cannot use auto? Auto div equals td div. Probably it doesn't exist. I don't know. Oh, it does. It does. Yeah, it does. If div dot. I don't think I can do that. Hold on. So what we want is OP's operations plus equal to dv dot remainder. If it's 0, then we do dv dot quotient minus 1. Otherwise, dv dot quotient. Right? dv dot quotient. And if operation is larger than max operation, then we break. Right? Okay. So once we're done, we say if operation is larger than max operations, then too much. Then we do we reduce too much. So low shall equal to mid plus 1. Else we say high equal to mid. Okay, so blah blah. Once we're done, we're gonna return low. Because at the end, this is not possible, so we do this. Yes, I think I can. I'm pretty confident in this one. This is 1760. So what we can say is use binary search. Yeah, this is a min max problem. So we use binary search. I mean O n log m, right? Where m is the difference between the max and the min values in nums. Okay, let's see. Does this work? No, it does not. One is one. Oh, I think this is the issue. Because min and max both are 9. But anyway, so 9, so it will be. Low should be 1. Then why you have a min, right? You really don't need min, you just need max. And this is also not needed. Right? You just need a max. And if you do that, why don't you just go high? Right? You can just go high. Right? And then you can do high plus plus. Okay. Submit it. Good. It's standard, right? This is what they call a standard solution. Just kind of slow. Okay, so apparently there seems to be a better solution. Let's take a look at a hint. What better solutions are there? What if we know the maximum size of a bag? What is the minimum number of bags you can make? maximum size of a bag. Yes. What's the minimum number of bags you can make? Well, it's the same idea. Oh, yeah, it says binary search. Binary search. Oh, that's the only answer, binary search. Okay, let's see. Left, right, get a max, perfect. Mid, if possible, right is left, okay. What is possible, go through. Operations is ceiling. Oh, that probably is. That probably is. Okay, that probably is, because we're using this, right? This is kind of slow. So update, this is kind of slow. My suspicion is that std div takes too long. Let's use a trick. Let's use a trick. At -1, right? I think it's -1 is ceiling. Yep. Ceiling x divided by y -1. Yeah. To get the number of ops. So basically here, don't do this. Ops plus equal to std ceiling. Yeah, you need C math for this, right? It's gonna be divided by double it mid -1. The trick comes from the official solution. All right, try it one more time. I refuse to believe it. How is this possible? I don't understand. You get it slower and slower, man. But we're doing it exactly the same. Hey, wait, what? What the hell? I don't understand. Absolutely don't understand. How come this is so slow? Well, technically you did a... Oh, so one more shot. This is actually slower. Using the ceiling tricks is actually slower. Screw this. Let's use modulo and division directly. No more trick. No more trick. So in quotient divided by mid, remainder mid. If r is equal to 0, we just go through this. OP is plus equal to R is equal to 0, then Q minus 1, otherwise Q. Right, this is as generic as it can be. I'll make sure everything works. It does. All right, let's try this one. There we go. There we go. The fastest is always. In conclusion, the fastest is always without any tricks, right? Any complex function calls or object creation. Good, it's a good problem, and we solved it. Voted, done. All right, let's try this. I mean, we already know how to do this, so I think it should be fast. 2, 4, 5, 8. Maybe I have this one. Hold on. 2, 4, 5, 8. Yes, I have this one. But I think this one, 3 queries, right? Let's revert this. Yeah, this is not right. Oh, this is the previous attempt I was trying to do this, and oh wow, this is the previous attempt. Oh yeah, I did this one before. 2024. Wait, hold a second. Wait, what? When did I do this? I don't know about this one. What the hell? No. It's impact. Like impact or not impact. No, this is not right. No, this is not right. This is completely wrong. And I'm going to just delete this completely, and we'll redo it. Yeah, we'll redo this. So this solution comes from the official, right? We find the height of the tree after removing each node, right? Then we store the result and can easily query it. Now to find the height after a node is removed, we need to do 2 rounds of traversals, right? 2 rounds of traversals. First we do left to right, right? And we do left to right and keep track of the height. This tells us the max height, right, of a node. Max height of a node when the left trees are considered. Right? Trees are considered. Then we do right to left and obtain the max height before a node is visited. Ah, looks wonderful. This height, right? This height represents the left trees. Okay, and then we do right and obtain a max height before the same node is visited. This height represents the right trees. Thus, the max height when the node is removed is the bigger of the left tree height and right tree height. Alright, so how do we do this? We will have a thing, and every time we keep track the current level, right? We keep track the current level. So when we visit a node, before we visit a node, we have the current max. Current max. Then we do need a current max. So we need something to keep track, and then we need a current max. So we need to save the max value. Okay, so we need a current max height. Okay, so we have a current max height, and then we have levels, right? We have levels, and okay, I need to do a function. Call it def BFS. We have a node. It's optional. Tree node. Right, we have a node. We have a level. We have level. We have is left to right. This could be boolean value. We don't return anything. Okay, so if not node, we just return. Okay, so this is simple. Otherwise, if is left to right. But anyway, so we visit this node, right? We don't visit, wait, hold on. We visit this node. Because it's me, right? So before I'm visited, so I'm removed, right? So I just need to know the current. So we also have to have a self dot max height after removal. Maybe need to be a dictionary. Maybe not. Maybe not a dictionary. message I've been asking, how do I put on contact lens? I keep opening my eyes for half an hour, and it's red and crying. I was like, I know exactly what you're feeling.
It's not for Chinese people.
I think this is exactly the case. It's really not designed for us. And people are giving suggestions, exactly my suggestion. And you need to make sure your fingers are dry and your eyelids are dry, otherwise you don't have the friction to keep your eyes open.
How can you make sure your eyes are dry?
Your eyelid,
Oh.
like around your eyes, has to be dry.
Oh.
Otherwise, just your.
Isn't it always dry unless you're crying?
Yeah, like that's why, like, if I could have put it on the first one or second chance, then it's gonna be like no problem. Then I go glue it around very far to maintain the friction. It's not easy. Well, that kind of easy. I push you. We should have a lovely. Oh shoot. Fantastic. A wonderful, gorgeous day. Waiting tomorrow. Enjoy your Tuesday. Can't wait. There's so many good things. So what is it? It's just for this day. The next day is not.
You'll never get back.
I never get back. All right, I'm back. Where are we? Yeah, we're deciding whether this. We probably can do queries, because these are the only ones that we care about. Hold on, I forgot the problem. What's the problem about? What's the queries? Ah. Yeah, let's just do a dictionary. I think it should be fine. Let's just do a dictionary. Okay. So basically now we say if it's left to right, then I always, right, because I have the current height, current level. Wait, how do we do this? So we start the level as 0, right? And then we move on. So when I visit the next one, the level is 1, right? That is its current height. But you need to finish the left and then decide your height. No. No, 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 no. You don't do that. Height, level. When you go to a children level plus 1, so when the level is the current node's level, right? The current node's level. But how do we know? Well, we have the current max height, right? Current max height. I think it's like this. Self. Oh, maybe we need. It was a default dict here. Okay, let's do a default dict. I don't think we have a default dict. From collections, do a default dict. Okay, so we do a default dict int. If I remember the syntax. All right, so self dot max this node, right, shall equal to max node and no self dot max current max height. So we do that first, right? And then I will visit the left. No, I do that first, and then I update self dot current max height shall equal to max self dot current max height. And level, right? So we update its level, and then we say BFS node dot left level plus 1 is, so it's true, right? So we go left first, and then after we finish left, then we do right. Then BFS node right, also true. Else, then we'll basically do right first, but this one will be false. And can we do this one more time? Nope. No. And this one will be false. Right, but the, oh jeez, self. So we do self.bfs. Can I determine the type of self.max? Do we have to do a type? Can I determine type of current max height? Because it's not defined here. Undefined. Oh, it's not. No. Did you just say void? I think it's none. I don't know how to deal with this. I mean, not defined here, right? But I think it shall work. So basically, when we do this, so we will do self.bfs root. Oh, value. Damn. Dot val. Wait, is it unique? Yes. Dot val. Right? Because there's no dot val. Okay, so root level 0. I think level 0. Let's see. Remove query 2, so it'll be 1, 2. No, remove 4. No, 1, 2. Yes, 1, 2, 1, 2. Remove 3. 1, 2, 3. Yeah, okay. So we have 0 and, yeah, we say true. Right, self.bfs no root 0, we say false. Then we basically say return for queuing queries. Right? So we say self.max queue. Already defined line 22. Huh? It doesn't allow this type of thing? I have no idea. Okay, let's do this. Def, I think it's initiate. Then we can just copy and paste. So we'll do these, put it in here. That should make people happy. Okay, so this way I can just say a dict of int. Right? Yeah, I think this make people happy. Not make people happy, make this thing happy. Alright, let's see if this makes any sense. Does it make sense? It bloody does not. Is it when 4 is removed? I got 4. Huh. How is that possible? Because I go left to right. Should be 1, 2. Right? It should be 1, 2. Unless, because I start with 0. The current height is 0. Right, now we go to left. Current height is still 0. Right, current height is still 0. And now here is still 0. And this becomes 1. It will be hard to debug this using our stuff, so I'm just gonna print it. Actually, it's good. We can print self dot this, and we print exactly the same thing after this. Okay, so now we can take a look. All right, so 1 is 0, 3 is 0, 2 is 1. There's a 1, 2 is removed. Okay, when 2 is removed. When 4 is removed is 2, that's correct. So the problem is on the other side. So I go here. How it becomes 3? Because you already considered it. Right? You already considered it before you go. When 1 is removed, how? Oh, I know how. I forgot to clear it. Yeah, my bad. So reset. Yeah, I need to reset. Don't forget to reset before second round of BFS. That is, oh, because I spelled it wrong. There we go. I think this is correct. We can remove the print statement. Remove this print statement. Use the example, run one more time, make sure it's correct, and then we submit it. Yep, that is the one. Simple as it gets. All right, I put into Nightmare because I did not solve this myself. And the solution has single traversal. So we cannot delete this problem yet because there is a way to do. You are kidding me. Anyway, single traversal. Subtree size. Oh. Oi. Oh. Eulerian tour. Eulerian tour. I think it's reverse order to do Eulerian tour. Darn. Darn, they got 5. Holy crap. Okay, this will take a while. That's fine. Yeah, we'll deal with this one at a time. All right, I'll see you guys tomorrow. Adios.